Okay, so hey everyone, and let's get started. So uh, today I'm going to talk about a quite hot topic in the world of AI these days. And if you have been following the latest trends in AI, you should have probably already heard of the buzzwords of AI agents. And today we will try to unravel this topic and we will try to find answers to the following questions. What is an AI agent? How they work? And how you can build them. So let's jump right into it. So if we look from a high level perspective, an AI agent consists of three major components. First, we have a large language model, which is an AI model that is capable of generating text very intelligently. And this model serves as the brain for the AI agent. Next, we have a prompt, which essentially is a text that we pass to the large language model. And most of the time, usually the prompt consists of some user question and instructions that guide the model how to respond to the user's question. And finally, we have tools. Tools are nothing more than just uh, functions written in code that allow the AI agents to interact with external systems and services. And the combination of all these three components make up an AI agent, an AI system that is capable not only to respond to user questions based on the data that it was trained on, but also to perform actions. What do I mean by that? Let me give you a quick demonstration. So here I'll show you the behavior of two different AI systems. On the left side, we have a system which utilizes a large language model. And on the right side, we will see a system that utilizes an AI agent. Now, if we look to the left side, and yeah, what I'll do, I'll ask the same question to both of the systems. What is the weather in Vilnius today? And if we focus on the left side of the screen, the large language model usually would respond sounding similar like, unfortunately, currently I don't have access to current weather condition, therefore I cannot really help you out with this request. But what I can do, I can suggest you how you can do that, where you can look it up. So that doesn't really help with the situation, with the question. But if we look to the right side, the AI agent would handle this in a different manner. Uh, so the AI agent would realize, okay, probably I don't have the necessary info to answer to that question, but what can I do? I can Google that answer on the web and use the top search result, take it and use it when constructing the response to the user. So basically, the AI agent does the search on behalf of the user. And now, when talking about these agentic systems, it is also important to mention that in order to implement them, you need to apply these AI design patterns, which I now cover briefly. So first, we have the usage of tools. Just like in real life, a builder needs some kind of a tool, in this case a hammer, to complete the task of hitting the nail. In the same way, an AI agent, in order to complete its task to explore the internet, needs a tool, in this case a web search tool. And so far, when I was talking about tools, I was referring to tools, to integrations that allow to retrieve information, but it's not limited really to that. It also could be integrations that allow to insert new data or modify existing data. Now, speaking of tools, it would be a sin not to mention Model Context Protocol. What is that? It's a new open standard that was not so long ago released by the company Anthropic. And what this standard allows, it allows for AI assistants to connect to external systems, data sources, business tools, and many other things. Why am I highlighting this in the first place? Is because currently many popular AI frameworks and also AI tech giants, including OpenAI, are currently heavily adopting this standard. And this standard introduces a new way how AI assistants interact with external systems, APIs, and so on. How does that look like? Let me show you in a picture. So here we have a situation where we don't have model context protocol. So at the top, we have our AI agents, each of them having their own custom implementation of tools, integrations to some kind of external APIs or databases. Now, how does this picture change when we introduce model context protocol? So here, the tools are completely decoupled from the AI agents. So we have the implementations of these integrations sitting in one place called an MCP server, which is accessible to all AI agents. And one of many benefits of these are: one, cleaner architecture; second, reusability of tool implementations; also faster agent development, and so on and so on. These were pretty much the main points that I wanted to mention about model context protocol. I won't discuss about it further because it's a topic of its own, really. I just wanted to really mention this so you could later on Google it and find more information on the web yourselves. Now, moving to the next design pattern, reflection. So what's the idea behind this? So imagine that we have an agent that is capable of writing code. And we ask it to please write some codes for some kind of particular task. And it does so. It generates some function based on our request. And usually that would be the end of that. But what the idea behind the reflection pattern is that we don't stop here. We take the response that was generated by the agent and we put it in a prompt, which sounds something like, okay, now check this answer that you generated, review it, critique it, and suggest any kind of improvements if there are any. And we pass this prompt to the LLM, not to the LLM, to the AI agent. And then the agent realizes, oh, okay, actually there is some room for improvement, and let me incorporate that and generate a new version of the code. And this process can be repeated, so on and so on, until it meets some kind of criteria that was defined by the user itself in the same prompt. Now, moving on to the next design pattern, planning. Imagine we have the following request from the user. Please generate an image where a girl is reading a book and her pose is the same as the boy in the image. Then please describe the new image with your voice. You have to admit that this doesn't look trivial, like you could do it in one go. And the idea behind this design pattern is that the AI agent, instead of trying to answer this in one go, it first plans all the necessary steps that need to be taken in order to solve this problem, and then executes it one by one until it reaches the final expected result. Now, moving on to the next and final design pattern, multi-agent collaboration. So what's the idea behind this? So instead of having a single agent that would try to help you solve your given problem, you could have a team of AI agents helping out to solve your given problem. So these AI agents could have different distinct roles, different responsibilities, and they would be working with one another in order to solve the problem that was given to the user. Now, in order to now to implement, how do you implement these like agentic workflows, taking taking into mind the design patterns that I mentioned previously. So one way, yeah, there's an option that you could implement it from scratch, but of course that would be too hard to do so. Fortunately, we have already frameworks that have already done that for us, and those would be agentic frameworks. And currently, we have quite a few of them already developed. Some of them have their own pros and cons. Uh, Today, I won't cover all of them here. I will focus on one of these frameworks, which is Crew AI, because it is quite popular among these. And now let's check how does Crew AI work. So in Crew AI, we have agents. Each agent has their own role, and these agents talk to each other. They pass information about the tasks that need to be completed. And these agents, they work with one another in order to solve one common problem. And in order to implement this kind of agent system in Crew AI, first you have to get yourself familiar with these 5 main concepts, which now I will cover each. So first, let's begin with the agent. So when you're building an agent in Crew AI, you have to define a set of attributes. The role of the agent, which defines what the agent is good at. The goal of the agent that describes what the agent tries to achieve. The backstory of the agent, which provides some additional context at what the agent is good at. Also, what tools are available for the agent to work with so it could complete its task, and so on. So this is theory. How does that look like in practice? So it's now time for some Python code. So I'll use a Crew AI project called Trip Planner as example. And this project focuses on creating a travel plan for vacation to some city. So in this setup, we have 3 agents defined. We have a city selection expert that is responsible for selecting the best city for travel destination. Then we have a local expert agent, which is responsible for getting more insights about the selected city. Then we have a travel concierge agent, which is responsible for creating the travel plan to the selected city based on the information that was gathered from the previous agents. And now let's take a closer look to one of these agents. So here we'll take a look at the city selection expert. So here, as I mentioned before, we have defined the role of the agent, the goal, the backstory, and also the tools that are available for the agent. And take notice that majority of these attributes, they're written just in plain English. So the thing is that Crew AI behind the scenes utilizes this text information to actually, under the hood, build prompts that are later passed to the large language model. Now let's move on to the next concept, which is tools. So in Crew AI, there are different type of tools available. There are built-in tools that, so basically Crew AI has an extensive list of integrations to different services, databases, and so on. It also supports built-in tools within LangChain. I won't go into detail listing them out here. You can check into documentation yourselves. But if you don't find something within that list, Crew AI provides templates how you can implement your own tools. And soon I'll show you an example of that. And finally, also Crew AI supports MCP tools. So this is in relation to what I mentioned previously. Why this is important? It is because that if you open Google and type in MCP server, you will see thousands of already ready-to-use integrations that you could use to connect your agent to. So this gives a major advantage against other agentic frameworks. So as promised, here's an example of a custom tool written for CrewAI. So what this tool does, it just performs a web search using a Google Serper service. So, and the implementation looks like so. At the top, we have defined a tool name in plain English, and below we have a Python function which simply does a REST API call to the Google Serper service. And yeah, that's pretty much it. And moving on to the next concept, which is task. So in CrewAI, when you're creating a task, you also have to define a set of attributes. You need to define the description of the task, what the task is about, what needs to be done there. Also, you can specify which agent is responsible for completing that task. And also you can provide hints how the output should look like for that task. And let's check out how this looks in code. And I'll use again the same trip planner example. So here we will have 3 tasks defined: the city selection task, the local guide task, and the travel plan task. And you may notice that just by the naming of these tasks, they kind of map one-to-one to the agents that I mentioned previously. Of course, this is just for this example. And when you are creating like tasks and agents in CrewAI, you can have like many tasks created and assigned to the same agent. It's just for the sake for this example. Now let's take a closer look at one of these tasks. So the city selection task. So as I mentioned previously, we define a set of attributes. We define provide the description of the task. Also within the same description, we capture some initial user input so that the agent would have something to work with from the beginning. And also we specify which agent is responsible for completing this task and provide hints how the format of how the output should look like for this task. Now moving on to the next concept, which is process. And in CrewAI, process is nothing more than just the order in which the tasks will be executed. And there are 2 types of processes in CrewAI. There is the sequential process, where the tasks are being executed in the same order as they were defined in the code. And there is the hierarchical process, where the agent decides in which order the tasks are being executed. And the final concept that you need to get familiar with is the crew. And crew is nothing more is just the combination of all the previously mentioned components: the agents, the tools, the tasks, and the process. All of this combined makes up a crew which tries to solve your given problem. And in code, the crew configuration looks like so. Again, returning to the same trip planner example. So here at the top, we capture some input from the user so that the model would have something to work with from the beginning. Then we read the configuration for the agents that I previously showed you. Then we read the configuration of the tasks that I also showed you in some previous slides. And finally, here at the bottom, we assemble all these parts together: the agents, the tasks, and the process of the here in this project is sequential. This is the default one, which means that the tasks will be executed in the same order as they were defined in the code. Now let's check how this project runs in action. So unfortunately, I won't use some kind of a fancy UI to demonstrate this, because CrewAI doesn't offer one for free. But here I think everyone are developers, so I think no one will mind if I show this demo using a terminal. So first what we do, we gather some initial input from the user. So this is nothing fancy here. These are just static questions that we use to capture some initial input from the user that the crew could utilize. And we pass this information to the crew, and then it kicks off. It starts processing and executing tasks. So first it begins executing the first task of selecting the best city for vacation. And then the appropriate agent, the city selection expert, picks up this task. And then what it does, it starts to think what to do next. And it figures out, okay, in order to select the best city, most likely I will need to gather some extra information based on which I can make the decision. So what it does, it begins to gather information on flights information based on the location where you want to go, also the weather conditions and top attractions from different cities. And once it decides that it has gathered enough information, then it makes the decision to which city to go to. In this case, it selected Vilnius, and it also provided all the previously gathered information as extra information. Now, once we have the first task completed, the crew moves on to completing the second task. And then the appropriate agent picks up this task, and in a similar manner, it begins to gather the necessary information, extra information about the selected city. And finally, once it gathers enough info, it creates a comprehensive city guide about Vilnius city. And after completing the second task, then the crew moves on to the third task, which is creating a travel plan. Then appropriately, the travel concierge agent picks up this task. It takes into account the previous information that was gathered from the agents, and also, if needed, gathers some extra info from the web, and finally creates like this ultimate 7-day Vilnius travel plan. So that would conclude the demo for this Crew AI project. Before ending the presentation, I want to mention a few important things to keep in mind when building and working with these agentic systems. First, monitor the costs. The thing is, these agentic systems, for them to work, you need to collect two large language models. Now, if you're connecting to a large language model which is not running on your laptop or your infrastructure, but on some cloud, on someone's cloud provider, those models, their cost is based on the usage of tokens. The bigger the prompts, the bigger the usage of those tokens. And these agentic systems, they tend to create quite large prompts if unchecked. So you have to keep in mind. One of the ways how to tackle this, one recommendation is to try to use Ollama, to set up Ollama on your infrastructure and try to utilize that. Or if you're brave enough, you can, of course, connect to a large language model hosted on cloud, but you have to keep in check the costs that are being generated. Next thing is we're using large language models behind the scenes. Hallucinations may appear, as always. So one of the ways how to tackle this, I would suggest to implement AI guardrails, which is a must when you're when you're implementing systems for production. And finally, use AI agents when needed. What I mean by that let's say if you have a problem that you have a feel that it could be solved with AI, it doesn't mean necessarily that you need to like implement like this like team of agents to solve that. Sometimes maybe it's just enough to have a good prompt and a call to the database, and that's it. Where I would suggest to use these AI agents is to use it when you have a problem that has a complex workflow. What I mean by that is that you may see like where's the end of the path, but it's uncertain how you can reach that the end of the path. There are multiple paths there, and you let the AI agents to decide which path to take to reach the end goal. And yeah, that would conclude my presentation. Thank you very much.
Thank you. Thank you, Robert. Does anyone have a question from the audience?
Please.
In terms of cost monitoring, does Crew have its implementation, or does it integrate with LangFuse or similar?
Regarding whether it integrates to something, I cannot comment, but as far as I recall, it has like an option to, before executing a call, provide estimates what would be the cost to the user, and then let the user decide whether to proceed, to make the call. And also monitoring capabilities, some like in a dashboard-like manner.
Okay, and does it have some kind of memory management to optimize for cost? Like short-term, long-term memory management.
They have the concept of memory. You mean like for retaining the history when talking?
For longer runs,
for
like
longer
where it
runs,
cascades into.
They do have.
Okay.
They do have.
Okay.
What kind of guardrails did you mean? Maybe you can give some examples.
There are different frameworks that implement them. Actually, there is this framework that actually is called the same thing, in the same way, AI guardrails. So you can pretty much Google it, and there is like this framework that could be an option. Also, there are NEMO guardrails that could be utilized. So currently, there are two these frameworks that could be used to implement there. Some of them involve just basic functions that implement regex to check the response that is being generated. And in NEMO guardrails, you actually utilize the same large language model to check whether the bot's response comply with with some kind of your defined policies, which you define in a prompt. Yeah, and also important when you implement AI guardrails, put them after the input and after the output, like before the input what the user sends, in order to check whether the user doesn't send anything malicious, and also to check after the response has been generated.
Thank you very much.